Hi, this is Bob Williams with Sifter Parts and Service in Wesley Chapel, Florida. Today we're going to do a short presentation on how to assemble, disassemble, gasket, and shim a CS-1 sifter. Randy Williams and DJ Williams and Tim Robinson are going to show you all the different parts of the sifter. Basically, all the parts that you see setting on the floor here are what make up the CS-1 sifter, which was originally made by the Ellis-Chalmer Corporation, then by Farrell Ross, then by Bluffton, and several other people have owned it over the years. We've made a lot of modifications and improvements to a very old, tried and true sifter, and we'll show you some of them as we go through this. This is meant to be an instructional video, and hopefully we'll answer all your questions. In front of you, you see an upper spindle, which is what goes inside the bearing housing. And Randy, if you just point to them, that'd be great. The lower spindle, the bearing housing, and the 4 stabilizer assemblies. We're going to put the bearings on them and then bring them back outside here. And we have the spider base, which holds up the bottom of the sifter. One thing on the spider base, this is precision machined so that it's designed to sit perfectly flat on a flat floor. If one leg of that spider base is high or low, it's going to throw the sifter out of its proper shimming. The other big X-frame is what goes on top of the sifter, and like the spider base is precision machined, and both pieces are stress relieved so that they'll stay accurate so long as they're mounted on a very flat surface. So we're going to go inside and show you how the bearings go on, so we'll take a break here. We've got the upper spindle. In the bottom of the upper spindle, we've got 3 plugs. And those 3 plugs are designed, grab a tool over there, Rand, so that if you ever have to take the bearing off, you can put 3 bolts or a fixture such as this in and press the bearing off. The 3 plugs just block the holes. First thing we're going to do is put on the thrust collar, that's good. Okay, we're gonna put on the thrust collar. Then we're gonna take the bearing, which has been pre-greased. We're gonna put some grease in the bottom of the spindle. Okay, what we're gonna do now is grease the bearing. We've already greased the bottom of the upper spindle. We put the thrust collar in place. Now this bearing has to be pressed on. If you're rebuilding the sifter and the bearing comes off real easy, you need to have a new upper spindle. This bearing has to be a press fit, otherwise it'll spin on the spindle. It should be put on with a 10 or 12 ton press. And what we do is just start it, and we'll take it over to the press. And Randy will line that up and press it down, and then immediately put on the snap ring to hold it in place. And it'll press on very smoothly. It takes about 10 tons of pressure. Then we'll put on our snap ring, and our upper spindle will be ready to go in the machine. If you're rebuilding a sifter, you want to make sure you take that snap ring off before you try and press the bearing off, or the bearing will not come off the shaft. Now we'll take the lower spindle we've already put a 90-degree grease fitting in the lower bearing. We're going to loosen the 2 set screws that are in the collar that secures the lower bearing to the lower spindle. So we're actually putting this bearing on. It slides right on. It now becomes the base bearing on the Sifter. We're tightening the 2 set screws up so that it won't move on the shaft and it locks it in place. Very important that those be tightened up securely. You don't have to tighten up so much that you break an Allen wrench off, but you just want it to be very snug. This bearing is a floating bearing. It's designed to compensate for a little movement in the bottom wheel. We're going to insert the key. And then since we're in a nice air-conditioned shop, we're going to put the filler ring into the bearing housing. The filler ring is nothing but a piece of plastic that takes up space in the bearing housing. And what it does is it eliminates you putting in an extra tube of grease. A couple changes we've made to the bearing housing since the Sifter was last redesigned. We now have a bearing plug that has a grease fitting in it, so it greases right to the upper bearing instead of pumping in it all the way from the bottom. And we also have a 1/2-inch taper that is put in so that you can start the bearing very smoothly and uniformly without getting it cocked. So now we're going to move back outside and assemble the Sifter. Okay, what we're going to do now is we've got the upper wheel turned upside down. The 2-inch weight is in place. We're going to take the bearing housing with no bearings in it, and we're going to mount it into the upper wheel. We're going to mount it so the bearing plug hole is 180 degrees from the 2-inch weight. That puts it in the right position. Now we're going to screw in these with the bearing housing bolts. They're designed to come flush to the top of the wheel. You don't want to put in longer bolts, otherwise you'll have a wearing problem on the bottom of your spindle. You don't want anything to rub. We designed this so you can take a socket, put it on the bottom of the holes, and tighten them up with an impact gun. All the holes line up all the way around. And then we're going to put in a bearing housing plug. And that has a grease fitting right in it. That's a change in design because what it does is it delivers the grease right to the upper bearing. The previous design, the grease had to be pumped up all the way from the bottom. Okay, now we're going to grease the bearing once again. We're going to lay the wheel down. Now with that 1/2 inch recess, the bearing will slide right in for the first 1/2 inch, and it'll be perfectly lined up to be driven in. It is a driven fit. When you take it apart, if you're rebuilding the sifter, if the bearing comes out easily, you need a new bearing housing. Obviously, these are two brothers that trust each other and have been doing this for a long time. It's driven in all the way, so the bearing is now setting on the upper snap ring. Now they're going to lay it over and put in the lower bearing. That lower bearing goes on a tapered bearing adapter. That tapered bearing adapter is then pulled up tight, and by doing that it locks the lower bearing in place. A couple things that are very important on the lower bearing, which we'll look at as we get into it. If you're rebuilding the sifter, to get the lower bearing out, you have to first remove the entire upper spindle, take out the snap rings, the filler ring, and then drive it out. And then putting it back together, you don't want to drive the lower bearing in all the way. You check to make sure which side the taper is so you don't put the bearing in backwards. Put your adapter in, and we'll grease it. Then we're going to start to tap it in, make sure we get it started squarely. Okay. Then we're going to lay the wheel down. We're going to take 2 drift pins. And with these drift pins, we're going to start to drive the bearing in place. We don't want to drive the bearing down past the first snap ring groove. Okay, what DJ is doing is starting to drive the bearing in. Then the most critical part here is we're going to put the snap ring in place so that when the bearing is driven in, as soon as the snap ring reaches the snap ring groove, it snaps in place. Once the snap ring snaps in place, they make sure that it rotates. Now that bearing can be driven in another 1/8 of an inch. But if you drive it in another 1/8 of an inch, when you turn that wheel right side up, the bearing will not be sitting on the snap ring. By doing it this way, we have the bearing top and bottom both sitting 100% on the snap ring when the sifter is in the upright operating position. This allows the bearings to float, which is very important for keeping the bearings running cool. And we have had bearings in bakeries last up to 40 years. What we're going to do now is tighten the bearing adapter. And the first thing we do is make sure the bearing adapter is pulled up all the way. It can be tightened with a drift pin, driving it around. We've made a special tool which just allows us to use the impact gun and then fellas, show them how you do it if you did it with a drift pin. If you do it with a drift pin, you would simply put the drift pin into a hole and drive it until it's tight, then bend a notch over to lock it in place. Now you'll notice when you do this that the upper spindle becomes very difficult to move. You may have to move it just a little bit to line it up. And then by bending one of the dogs down, it'll lock it in place. Then what we're going to do is hit it with a 4x4, and what that'll do is free up the upper spindle. And it'll spin freely and perfectly uniformly. Now we're going to put in about a tube and a half of grease, and we'll turn the camera off so we don't bore you with details while we fill this up with grease. And what we've done is we've greased it until the grease is coming right through the lower bearing. That means the upper bearing and the lower bearing have been literally pressurized 100% full of grease. Now we're going to set this aside and we're going to start on the lower wheel. So we're going to bring the spider base into the middle. I would be using the forklift, but the boys will pick it up and move it. We set it on a couple of 4x4s. That simply gives us ground clearance. Now we're going to take the lower spindle and we're going to put it We're going to take the lower spindle and bolt that in place. That goes onto a machine surface in the spider base. It's simply a drop-in fit. While they're tightening up the bolts, should you be rebuilding this sifter, you would simply reverse the process. On the upper spindle, what you would do is loosen the bearing collar, the bearing adapter, and after you back it off 2 or 3 turns, Tim, take the hammer and show them where they'd hit the bearing adapter. After you back it off, the bearing adapter in the upper wheel, what you do is back off the bearing adapter, and then you would hit it. Don't hit it. Just show them where you'd hit it.
Where would you hit it?
Right on the edge.
Right on the edge.
Yeah. And what that does is unseats the bearing adapter. Then we take a brass rod and drive the upper spindle completely out. And driving the upper spindle completely out will then allow you to take out the snap rings from the opposite side and drive the lower bearing out. You have to make sure all the snap rings are taken out before you do this. While DJ's tightening the nuts up, what Randy's doing is putting the lower shiv wheel on the forklift. He's putting in 4 1-inch shims, which can be 4 pieces of key stock, 4 pieces of lumber. What that does is when it's pulled up against the bottom of the spider base, it holds the lower wheel perfectly flat and level with the spider base, and when the magic grip bushing is in place, it lets it pull it up perfectly flat and level. And that way when the machine runs, there's no wobble in the lower wheel. If you don't have those 4 pieces of wood or key stock in place, and you just pull the magic grip bushing up, what'll happen is, due to the weight on the bottom of the lower wheel, it will pull up unevenly, and even though it'll tighten up, when the machine runs, you'll get a wobble in that lower wheel, and you'll take out that bottom base bearing very quickly. So it's very important that that lower wheel runs flat and very true and level. Now this bearing is a link belt bearing. There are other bearings that are comparable, but they will not work. The only bearing that is machined to fit in there is a link belt bearing. Okay, Randy will bring in the wheel now. Okay, what we're going to do now is take the magic grip bushing, which is made up of a taper lock bushing, a collar, and a snap ring. We're going to line up the keyway in the magic grip bushing and the keyway in the lower spindle, and we're going to push it in place so that we can put a cotter pin through. That cotter pin prevents anything from falling off when the sifter's in operation. Then we're going to take 3 hex head cap screws and we're going to pull that magic grip bushing up very snug. The taper on that magic grip bushing exactly matches the taper in that lower wheel. So when you pull the two of them together, they lock in tightly, just like a magic grip bushing does on a motor spindle. Now to remove that, you've got 2 pusher holes in there. You would simply take out the 3 hex head cap screws, take out the cotter pin, put it into the pusher holes, maybe spray it with some WD-40, and very uniformly thread in the cap screws so that it pulls the magic grip bushing out. Should you break the collar on that magic grip bushing or not be able to get it apart, all you do is take the entire assembly, turn it upside down so that it's resting on the floor, sitting on top of the lower spindle, and we'll show you that when we put it down, and you tap it with a couple of 4x4s and that'll break it right loose. Okay, we're tight now, and now we'll lower the forklift. What we're going to do now is just flip the base over. This is not normally done in a building process, but we're going to show you how you would get that wheel off if you broke the magic grip bushing. You'd simply flip it over like that, and by taking 2 4x4s, if you were to tap it down right there in that position, you would drive that wheel off that magic grip bushing. It makes it very easy to come apart. Now we'll flip it right side up and we will put the upper wheel on. Notice the offset where the weights go on the bottom. We're going to have the weights 180 degrees apart. That means that the weights on the bottom wheel are going to be exactly opposite of the weights that will be on the upper wheel. Each sifter is weighted individually depending on the number of decks. The number of decks is determines how much weight you put on that wheel. Now we're going to bolt the upper wheel in place. What we typically do is start one bolt while it's on the ground and then pick it up with a forklift.